welcome to the second day of our Design to Manufacturing event. My name is Paul Radine. I'm the Vice President of Digital Manufacturing, and I'm coming to you live from inside of our Digital Manufacturing Lab here in Brooklyn Park. So if you happen to be joining us via YouTube, there's a link below where it says register. If you can click on that, that will allow you to join the various breakout sessions that we have later today. So I encourage you guys to check that out. So in our general session today, we'll be highlighting and speaking to a couple of our 3D printing partners, both Markforged and HP. Greg Mark will be joining us from Markforged, who is the founder and CEO, and I'll be also visiting with Ramon, who is the Vice President and General Manager of the 3D printing division at HP. Both Greg and Ramon are leading the charge in the additive space for their respective companies, and we're extremely excited to have them join us here today. So let's get things underway. Our first guest joining us is Greg Mark from Markforged. Hey Greg, how are you?
Great, Paul. Good to see you again.
Good to see you. Unfortunately, we're not live this time, right?
Right.
Hey, before we get started with some of the, what do you think of my backdrop here?
I was going to say, you've got a beautiful printer behind you.
So before we actually start talking about this stuff, let me ask you a couple questions because one of the things that took place, obviously, over the last 6 or 7 months is we've had this pandemic and all these situations with the healthcare providers and the PPE or the lack thereof, right? But I think it's absolutely amazing on how the entire additive community as a whole really kind of banded together. And I know that Markforged was a huge part of that, as well as other 3D printing companies and the community in general. But I just wanted to get your thoughts on that. What are your thoughts? And do you think that this, was this an eye opener for everybody as it relates to the disrupted supply chain?
Look, it's a great question, Paul. And I think a few things. Those of us who've been in 3D printing for a while know that we're really about supply chain optimization, right? So getting parts where and when you need them with the right material properties, the right strength, et cetera. What COVID did is it basically destroyed the long-lasting supply chains that we've had around the world. And the most acute example of this was getting PPE. And the 3D printing community did a phenomenal job of stepping up. And we personally printed 250,000 nasal swabs. So for testing of children in various hospitals, we printed face shields, things of that nature. We then did, because we can't obviously distribute enough from Boston, we then airdropped. We wrote some software to let us airdrop all the already approved in use at major hospitals in New England face shields to every Markforged, the tens of thousands of Markforged customers around the world. So we were a bit of a hub there, and then literally hundreds and hundreds of Markforged customers printed out PPE for their communities. It was it's an amazing way to get products to where they need to be infinitely quickly, right? And I think that was I can tell you for a fact that was a big wake-up call for a number of people, because we will announce later a very large deal that will help make sure one state doesn't have this problem again.
Right, that's awesome. No, it was really exciting to see, and I'm glad that Markforged, played such a key role in that. So let's hop into some items here. Obviously, we've got the Metal X system here behind me. For those that aren't familiar with it, it is a system, right? Rather than just a printer. We've got the printer over here. After the part is printed, we debind some of the plastic powder, or some of the plastic around the metal powder in a wash station here, and then we finally sinter it, and then we're left with an awesome, completely usable metal part. So one of the things that Markforged has been working a lot on is the material science side of it, right? So can you give us a little bit of an idea on some of the different various materials? And I know recently, I think the latest one to come out is copper. So if you want to kind of touch base on some of those.
Yeah, so copper's a really cool one. So copper's cool because, we have stainless steels, we have 17.4, we have Inconel, 625, we have some tool steels, which are great. Copper's interesting because you can't make it any other way. Okay, so there are other 3D, even with a DMLS process, the problem they have in DMLS is twofold. One, the powder reflects the energy,
Hmm.
Two, as everybody knows, copper is so conductive that it can't, instead of creating a small melt pool, it sucks the energy back down into the powder. So you can't make high purity copper parts with DMLS currently, right? It's a bit of a science experiment. People try it, but you can't do it. We have a fundamentally different, as Paul mentioned, process for making these metal parts where the printer will shape the part, right? And it's shaping it with a combination of plastic and wax and metal powder. And then you wash it and you wash out the wax. Then you put it in the sintering furnace and you're now vaporizing the plastic. But because you're heating the entire part evenly at the same time, you don't have the DMLS problem of the laser bouncing off the powder, or number one. Number two, because copper is so thermally conductive, you actually get super even heating, which is exactly what you want. So when it comes to sintering, it shrinks pretty repeatably and accurately. So this is one of the killer apps for the Metal X system has been copper. We've seen people make literally major automotive companies in production are using weld clamps that are 3D printed by on Markforged printers, and they're
Yep.
using them on production cars. So you may be driving one.
That's awesome. Hey, I'm curious, when it comes to the material science and that was, again, we've got, various tool steels available, stainless and so on. In purely just the development side of it, was copper kind of a more complex one than some of the other materials that are available?
Oh, it was a huge pain in the butt, right? So why? So the real problem with copper is getting it oxygen free, right? So everything at every step you have to make sure. And aluminum loves oxygen a lot more. But keeping the copper in a situation where it's not heavily oxidized and where you get like it's very easy to make something that looks like copper. It's very hard to get the properties that you want, right? And one of our like core tenets is there's no point in making something that looks like copper and doesn't work like copper,
Right.
right? So we waited and we spent the time to continue to do development until we got to the point where we could actually get copper that people can use. And people are using it for antennas and like crazy, crazy stuff.
Yeah, no, that's cool. Yeah, the material science is quite the complicated venture, I'm sure. Hey, I want to switch gears a little bit because everybody really thinks of a lot of 3D printing companies, maybe Markforged as well, as a hardware company, and because we're dealing with the hardware all the time, and I think a lot of times we may take for granted what's going on from a software perspective. Now, for a lot of companies that aren't familiar with Markforged, Eiger is the software component that allows you to bring your solid model in. It also allows you to lay down different carbon fiber and in the orientation that you want that best suits your needs or your parts needs. But maybe you could just highlight on Eiger, and then after that, I want to ask you a question about a newer release of software that you guys are having as well.
Yeah, sure. So there's a couple of things. Our design philosophy is that it ought to be incredibly easy to start 3D printing, to get your first parts out, but at the same time, you ought to be able to have full control. So we have what we'll call like the easy button. So if you want to print in carbon fiber or print in metal, you don't have to. You can just hit the slice button. It will figure out everything for you. It does a bunch of math to try to maximize the stiffness and strength to weight, like all automatically. Okay. But you can also go into this layer editor, which is kind of like X-ray view, where you can see inside the part, you can see exactly where every line. And literally, if you're an aerospace company, we have some that do this. If you want to if you've done FEA simulation, you want to prescribe the exact angle of every layer, you can do that, right? And so we like to have that huge dynamic range between incredibly easy to use for somebody who's brand new to 3D printing, but with that exact same software package, you can precisely control every aspect of your print. So we have easy to use and then full control. We also have like a few different versions. Okay, so the vast majority of people use online. So we're the only company to have ISO 27001, which means that you can store your files online and they're safe, which is great.
Yep, that's awesome.
Which is totally, it means that you can securely work from home. You can monitor prints from home. In fact, Paul, to your earlier question, one of the things that we saw in COVID, we try to make our printers portable because we sell a lot to the military. So a whole bunch of Markforged customers, like thousands and thousands, took their printers home during COVID.
Mm-hmm.
Right? We see
Yeah.
it. We see the amount of prints on the weekend has gone through the roof because people have taken their printer home. They're like socially distanced, printing parts out to keep their assembly line working. They're dropping off parts at work. It's been great. We also have, for the military, we have offline software, right? So what does this mean? It means like if the cloud is not an option, you can get a full-featured offline version that is STIG compliant, which means that that you don't have to jump through hoops in order to use it in like tricky places.
Right. Yeah, I mean, it's great. It's great to have those options, right? Because different companies, or the military, government, have different needs as it relates to being in the cloud or not. But I think the cloud's been an absolute fantastic option for everybody to be able to store that and utilize that. So one of the other software that I want to talk about is Blacksmith, because that's really essentially bringing AI to manufacturing. Isn't that right?
Yeah, so this is actually really cool. We're super excited about it. So if you have a Markforged industrial printer, X3, 5, or 7, will be the first release. There is a laser that we've been installing since 2016 for the sole purpose of basically doing what Tesla does with self-driving cars, where it currently measures your print bed, calibrates your extrusion bead, does all these things to make it great. What a future software update will do is enable it to measure this laser is used to measure, in its other life, is used to measure the flatness of a hard disk drive.
Wow.
Okay, so its Z accuracy is 1 micron. It's nuts. Okay, it's on every industrial printer we sold. Okay, it will scan your part while you're printing it automatically, figure out the dimensions of your part, and do corrections.
Yeah,
right.
that's awesome.
So the first, it's like so instead of you designing a part, let's take this iPhone, and you go in the traditional 3D printing process. You design this part, like every manufacturing machine in the world, it comes out and there's some tolerance and you have to make some modification. Normally in 3D printing, you've got to go back to CAD to make that modification. You've got to copy your model, now you're breaking the model, you're measuring, you're changing things, huge waste of time. In our vision, where this goes is you print the part, the printer measures it while it's printing it and automatically corrects for it. You never have to go back to CAD and break your model. Huge time saver.
Yeah.
Right? And more importantly, just allows you to get the part you want without all the fuss.
Right. No, that's a huge time savings, and ultimately, there can be some very bad things that happen when people start messing with the models, right? In revision and finding out that they also use a traditional manufacturing that they've potentially, converted for
We've seen
additive.
it so many times. We've seen it so many times, Paul. It's like this will be a massive simplification.
Yeah, that's awesome. Well, we certainly look forward to that one. So. Now let's, if we can, as much as you can, you're the guy to ask this question. What's the future look like, right? How much can we look behind the curtain at Markforged and see what's gonna come out next?
Look, I think one of the things you're gonna see is that so Markforged currently has parts flying on space station, flying on the F-35, flying in commercial aviation. We have parts pretty much in every high strength mission critical application. We have parts in medical. We're already there. So what we're doing is we're making larger, faster printers for end use production parts, right? And not just again, it's the same way we talked about copper. Not just to look like a part, but to actually do what it's supposed to do, inclusive of the quality control. This means that when you look at the upcoming generations of Markforged machines, you will be able to print aerospace parts on these machines with known good dimensions, right? And the part will come off certified, right? And so what this means, and by the way, if you're not in aerospace, the production line of the top automotive companies, when that production line goes down, it's a huge cost. Okay. So being able to have known good parts that are high strength and ready to use directly off the machine is where we're going.
Yeah. So if you were to take a look, what was it, 2012, right, that you started?
2013.
Or 2013. Okay. So since then, I mean, you always, I met you very early on and started talking about, the vision. I won't even talk about some of the very early parts that we were struggling to maybe get the support structures off. And I remember writing you an email on how excited I was when the software development team basically created that accordion way of pulling the supports off, which is phenomenal, right? But from where you started in 2013 to where you are today, so did you run into any forks in the road that were a little, speed bumps or even blockades that you bumped up against where you ended up having to pivot a little bit more and go in a different direction?
It's an interesting question, Paul. I think first I remember your email. I think it was all caps, and it might not have been politically correct. That
That is the email.
Yeah, excitement of things. And I think that's one of the most important parts of this conversation. Actually, our philosophy, and you mentioned that the software. Our philosophy has always been the printer should get better every month you own it. Okay, and this has really been like really a paradigm shift when you think about buying pieces of hardware and manufacturing. Okay, when you buy a CNC machine, it doesn't get better.
Right.
Okay, I have a beautiful Porsche 911, better every month, right? You get a Markforged printer, every time a software update rolls, it literally gets better. Okay, so we had like hundreds and hundreds of customers who have gotten speed updates to their X7, prints twice as fast, right? You have on the Metal X, your Metal X system now has a high speed mode,
Yep.
right? Which means that it's a sintering run, which used to be industry leading 27 hours. We pushed a software update that brings it down to 17 hours, which is nuts, right? And brought down the operating cost a factor of 10, right? So that's what we do in software is not just make it easy to use, but we continue to innovate on the technology, and then we push that out. Okay, so what have been the speed bumps? Look, the first and weirdest speed bump was 3D printing crashing. So when we started this business, Stratasys and 3D Systems were each like $5 billion businesses. We built these crazy printers. Paul, you remember we debuted the Mark I at SolidWorks World. It was crazy. The reception was amazing. And then we shipped a bunch of them. The weirdest thing is how many interesting applications customers have found. That was the thing I didn't predict. Our customers are so creative and so intelligent. They've just done amazing things with these printers that we never even thought of.
That's right.
Couldn't have been our wildest dreams. And that's been the best part of this. The weird things are speed bumps. 3D printing crashing was weird. We had to raise money at that point, shortly after there for less than we had expected, but company continued to grow beautifully, and it has been a wild ride. It has been a very wild ride. And I'll tell you, I think really going back to your first question, it all kind of came together in the PPE. We spent, I can speak for myself, I spent so much time building the business. I never really thought about kind of where we'd come, right? And when we had thousands and thousands of Markforged customers around the world printing PPE for probably the biggest disaster disaster that will happen in my son's lifetime, it was wow, we have thousands and thousands of printers and people who know and love how to use them, and they're now supporting their communities instantly. It was an amazing feeling.
Yeah, I think one of the other things you highlighted it, a lot of companies go into looking at 3D printing for one particular use case, right? They kind of identify something that they think is going to work, and the next thing they know, they're off in 20 different directions using it for all different types of purposes. And I think that that's one of the beauties of, which segues actually into the entire Markforged product line, because it really allows every company and or any company to invest in the Markforged printers, because you have a very affordable desktop printer that gets people familiar with it, just starting to use it, and it really just creates those creative juices to eventually maybe ramp up to something a little more on the larger scale side, similar to the Metal X.
Yeah, and I think, and Paul, actually, it's been one of the things that's driven our metal adoption is that we effectively use the same printing process for everything we do, right? And HP calls these print engines, right? So whether we're printing carbon fiber or metal, it's the same printer, right? It's literally 98% of the same pieces, right? It's the exact same software, right? You can it's the exact same print nozzles, everything the same. So you can literally and it's not just customers. It's it's at every level. So you'll get high schools, you'll get colleges, and they'll have a bunch of desktops and light industrials. And then these people will graduate and go take your pick, work for Siemens, and then buy Metal X, because it's literally the exact they know exactly how to use it. All the design philosophies are exactly the same. So they can seamlessly go from $4,500 printer up to like a $200,000 printer and prints like every material they can imagine.
Yep.
Right. That has made it really easy for people to kind of adopt it. And to your point, 3D printing is a mindset, right? It's like learning what additive can and can't do and how to apply it is a mindset that it's a journey that each company goes through. And when they get it, it's beautiful.
Yeah, no, I couldn't agree more. That's awesome. Well, Greg, I appreciate you joining us today. I unfortunately, we're obviously not live. I think we've got incredibly used to the video. I don't know if I'm the biggest fan of it, to be honest with you, but I'd much rather be seeing you live at one of our events like we've had you appear in years past. But we appreciate all the things that Markforged is doing. We look forward to the future, and take care. I appreciate you joining us.
Thanks, Paul. It was great to be here. Enjoyed it very much, and look forward to the next time we can share a drink.
Yeah, absolutely. We'll see you, Greg. So for those of you that want to learn a little bit more about Markforged printers, we have a recorded version of a live stream event that we put on a while back. It is called 3D Printing You Have to See to Believe, and you can find that at on our website under hawkridgesys.com and underneath the Resource Center. So now I've transitioned over from just a little ways across our digital manufacturing lab to another spot where we have the Model 5200, which is the top-of-the-line production system from HP. And joining us to talk a little bit more about the 3D printing from HP is Ramon Pastor, joining us all the way from Barcelona, Spain. Hello, Ramon.
Good morning, Paul.
How are you doing?
Great to be here.
So you're 7 hours ahead of us, so we probably caught you a little bit closer to dinner time.
Don't worry. Actually, in Spain, we have dinner at 10 p.m. So
That's right. Tapas, right? So you got a lot of smaller meals. Awesome. Hey, before we hop into again some of the technology, I was talking with Greg Mark a little bit earlier about all the disruptions in the manufacturing supply chain, and again, HP played a tremendous role as part of that PPE, developing parts for PPE. Matter of fact, the system behind me, was heavily involved in that effort as well. We had a number of our HP systems running parts from across the country, getting those PPE into healthcare workers and so on. But not just from I think, the challenge with the manufacturing supply chain disruption was heavily focused on the PPE, but let's talk about a larger scale from that. And I'm curious to get your global perspective of where do you think additive will play as we move into the future after we've been exposed to something so disruptive like the pandemic?
Yeah. That's a great question, and I think Mark also referred to it in a very appropriate way. For us, for everybody, actually, the pandemic has been a watershed moment where basically we have had to combine basically the response to this global healthcare crisis while dealing our personal issues, working from home, taking care of our loved ones. Having the kids without the school, while basically maintaining our businesses on continuity with all the challenges that it has. But really, to your point, what has really showed us and showed many industries is that the current setup of the supply chains, the current traditional manufacturing methods, has its shortcomings, has its limits. They are very efficient, they are very cost effective, but with the premises that you have a stable supply and a stable demand. And when basically you have disruption of both of them, basically the things doesn't work that well. And on the pandemic crisis, we've seen actually disruptions on the supply with companies shut down, countries shut down, whole supply chains that were disrupted, and breakages or changes on the demand side with the peaks of unforeseen demands on, for instance, you said it, medical devices, PPEs and others. So what has been great first is the 3D community basically getting together to react this and fill the gaps. What we have seen is basically that we've moved as an industry from understanding the local needs to design things that actually we had no knowledge about, masks, nasal swabs, respirators, prototype this, qualify this, certify this, and then produce with our own printers, with our partners printer, and you are a great example of this. All of this within weeks. If you basically have asked us what would have taken last year, I would have said 18 months to do all the process. We have done this actually within weeks, 4 weeks, 6 weeks, 8 weeks, it depends on this. And with a variety of things. And actually I had with me some of the parts that we did. I don't know how well we'll see. This is basically a respirator, full field respirator that actually we designed with some partners, and actually has been on the field actually saving lives as we speak. The nasal swabs have been actually a great other story where we got very soon the FDA okay to move forward, and countries like Canada, for instance, massively adopting these PPEs. So all in all, on the last months, we've been printed together with our partners more than 4.5 million parts that really had impact. So really, and the most important thing is basically what happens now. I think that industries and companies have taken note about this. The speed of reaction, how basically having a distributed manufacturing network really helps, because basically you produce what you need where you need it. So basically the response times are very short, but also the how we could repurpose manufacturing lines that were designed for do certain things to, in question of hours, do totally different things. And you probably have heard the story of Smile Direct, that basically they had this on demand on dental, and basically within an hour they repurposed all the manufacturing lines to produce masks and facial face shields, for instance. This is the beauty of digital manufacturing, and I think that when you have a crisis, sometimes this is a catalyst for innovation and for change. And I really believe that this will be a catalyst for change.
Yeah, I agree. I think it's as bad as the pandemic is, right? It definitely has brought technology and the community together to respond to that. So I think it's been amazing to see. And frankly, the HP multi-jet fusion technology is a great product from not only some of the very complex designs that you showed, but also the speed of it, right? And that's one of the advantages that we can really take in good use for these types of situations, and get a lot of parts printed out very quickly. So let's switch gears just a little bit. Over to the left of me, off camera, we don't have enough cameras set up in our digital manufacturing lab, is the 580, right? The 580 is a full color-enabled printer. And one of the things I was just kind of curious of, a lot of people think as the 580, or I should say color in general, is more for just purely cosmetic purposes. But as we go out and visit with customers, we're finding a lot of other use cases for color. And I was wondering if you could just share with the audience a little bit about what HP as a whole has seen in utilizing color for more than just strictly cosmetic purposes.
Yes. Another great question. The way I think color is actually in three aspects. So why would you like to produce a part in color? There's three reasons. One, that is the most obvious, is basically as a representation of nature, and basically you print things in color, because basically nature is color-wise. So basically when you want to do the simplest example, a figurine, that's obvious that you need basically color. But that's basically a type of application which is interesting, but I would not say fascinating, because actually it's starting to grow, but it's actually bounded right now. The second reason you might actually do color is basically to produce a part that basically has the same look and feel as the designer actually had anticipated. And you want to do this either for concept prototyping, because you want to show your customers show, your management show, somebody else how the final part look like, or because you're doing the final part and actually this is basically the color that the designer had in mind. Now, the limits of this, also prototyping, that's great. On the final part production, right now you need to actually have a very good color matching to be able to do this. And unless you can produce very good Pantone colors, this has limits. Right now, obviously, most of the parts that actually need the color go through some finishing, some painting, some coating. The last reason that you would do color, for me, is actually the most interesting one, and actually the one that we see most customers doing, and actually the market really expanding as we talk, which is basically to display information. Color is actually a way to display information like, for instance, how, in the case of a tool or fixture, you should orient it, or basically put QR codes to basically showcase more information, or basically making sure that when you put a tooling, you need to put another tool, and basically where the two intersect, this is basically noted. Or basically information for medical. Basically, when you do medical modeling, basically is when basically this display information can show information about basically the density. It might be basically where in a case of repairing an operation, where the part that you need to remove is, or in the case of mechanical engineering, you can basically color the part with the simulation of the heat or the fatigue that you will have, or the stress of the part. And this is where color makes a huge difference. Makes a huge difference to communicate, to work together, to take action. So from the three cases, basically, again, represent nature, have a fidelity to what the designers look, and display information, both actually have a lot of potential. I think that the third one is the one that we're seeing right now, more momentum on customers that are adopting.
Yeah, we've seen that as well. And a lot of people, without really kind of fully thinking it through, they say, well, we can put a sticker on something, right, to give it a little bit of a direction or instruction. But if you can immediately just print on the part without doing a second application and having additional artwork done and go through the entire process of that, why not do it, right? So, I mean, it makes perfect sense.
Or when you want to do a lot of iterations, and you basically print to the bucket like 20 iterations of a part, and then you need to figure out each one refers to which design. So it's a great way to track back the intent that you wanted to do to the part.
Right. So let's get back to the 5200 here, and let's talk a little bit about some of the materials. So, one of the most common materials that we tend to see our customers using is PA12. A very versatile material, extremely strong. A lot of companies are using it for, different types of enclosure and even watertight applications and so on. And then also PA11, which is a little bit more of a ductile material, perfect fit for live hinges or snap fit conditions and things like that. But we've also got PA12 with glass beads, and also the newly released polypropylene. Can you tell us a little bit more about those?
Sure. As you said, the PA12, 11 are very versatile materials. But basically, in our aim is to provide designers, engineers, producers the flexibility to expand their applications. To expand the applications to basically more rigid, better for dimensional accuracy materials, like, for instance, putting glass beads. Moving to elastomers, actually, we have introduced on the last year 2 new elastomers, 2 TPUs, one from Lubrisol and one from BSF, that actually expands quite a bit the application that you can do from sports goods, helmets, footwear, the midsoles, protection. Thinking about RoboSkin, we have actually customers printing skins for the robot to be able to interact with humans. We just was having an interview with one of our customers, Oxler, that announced that basically they're producing seats for Porsche. that are personalized.
Okay.
I mean, using the TPU. So it's the number of application actually is expanding a lot with elastomers. And you mentioned the last class of material that we just introduced a couple of months ago, which is polypropylene PP. PP for me is probably the most exciting material that we've done on the last months together with TPU. PP, if you think about this, is actually one of the most popular plastics that you can see on the real world. Basically, you touch whatever things that you have on your office, and the beds that PP is inside them. It's huge, huge use on automotive, huge use in many different applications. So from a point of view of trying to mimic the properties of this widely used material, that's fantastic. But also come with great properties: chemical resistant, low humidity absorption, ductility, and what is very good is actually the ability for this 3D printed PP to weld to injection molded PP. So in mixed environments where you have assemblies of injection molded parts with 3D printing parts, the ability actually to weld both is fantastic. So having expanding applications based on these mechanical properties are fantastic. The second reason is cost. This is by far actually the lowest cost material that we have introduced. Not only because of the cost per kilo of the part, but because also you can reduce 100% of the surplus material that you don't use on a build. So both from a sustainability perspective, but from a cost perspective, this reusability is very important. So we are very excited about this introduction, and the applications that we see being able to expand are enormous. No? From I talked about already automotive applications, interior part, fluid systems, HVACs, and the fluid system. Actually, I was talking about before the electrical cars. Actually, have a manifold that actually we're printing for some of the automotive parts on PP, but also for industrial applications, machinery parts. Piping again, medical devices, and again a myriad of consumer goods application. And which, by the way, I'm going to do add on to this. We have in HP a virtual booth that actually you want to click with this event and go through the demo center on Palo Alto. You will see actually some live and some applications that actually we have done on PP that are showcases. So very excited about these new materials, especially TPU and PP, and I think that will help us a lot to expand on applications because of the material properties, but also because of the lower cost of it.
Right, and that's awesome because, you know, one of the things I was just going to mention to the audience that maybe aren't so familiar with the HP printers, since it is a powder-based system, right? It allows for, number one, no support structures, which is awesome, and then as Ramon had mentioned, we have the ability for reusability. So we recapture all of that extra powder that's within the build chamber, and then that gets brought in through the processing station and then refills into the build unit to create new parts. So, you know, depending on the type of material, the percentages may vary a little bit, but it's very high reusability, you know, 70, 80, all the way up to even 100%. So that's fantastic. So Ramon, let's highlight on a little bit on a different material side. We talked a little bit about the various thermoplastics and so on. Let's talk about metals because, you know, HP has gotten involved with metals and metal jet technology. So if our audience goes out to the website, whether it be Hawk Ridges or HP, you'll find the metal jet technology. Can you give us a little overview of where you're at with the metals development?
Sure. Metal Jet, as you say, we announced this, that was on 2018 as basically a technology preview, but also we gave the first alpha printers available to some of our partners to begin basically to qualify applications. So basically we sign off a number of partners, GKN, and Parmatech are two good examples. GKM basically is one of the leaders of MEMS, metal injection molding printer, very strong on automotive, which we already have some engagements, some applications with, for instance, Volkswagen producing outboards. Parmatech, more partnered, very engaged with some consumer goods, but also from a healthcare perspective. So we have deployed a number of these alpha units while we basically keep developing the technology which is supposed to be launched in the next year. So right now, the progress on technology is fantastic. The progress on application, it's great to the point that actually we have announced a couple of weeks ago new partnerships and new use cases that actually we are beginning to print as we speak the parts. So even if actually the product is not commercially available, for the partners and for the alphas, actually we do provide machines for final part production. One of the partnerships that we have announced is with Cobra Golf. Cobra Golf, for the ones that you like to do golf, here in Spain not very popular, but I'm sure in the US it is one of the leading golf equipment manufacturers that basically it's partnering with us and Parmatech to put together a roadmap of personalized putters, club heads, and other equipments for golf. Another example, totally different industry, is the partnership that we have with the US Marine Corps to produce replacement parts for their amphibious assault vehicle. This amphibious assault vehicle is actually 40 years old and still has 10 to 15 years of service. So the problem that they have is about replacement parts. So we will produce in 200 plus units, 200 plus parts, replacement parts to this amphibious unit. So it's a great example of how while we continue to develop the technology, since it's publicly available, we do engage with a lot of partners to begin to produce, as of now, real parts that go to the field, to the market, are fully functional, and basically we keep qualifying the applications while actually we close the technology.
Yeah, that's awesome. We always like to see new development and things that are going on, and again, a little bit behind as far as not publicly released or out to the majority of the public, but given the opportunity to view some of the partners, there's a lot of different case studies that I saw on the HP website as it relates to some of the companies that you're working with. I even saw one, I think, on Volkswagen that was doing some parts, and they were talking about doing mass customization and so on. Do you know much about that one, Ramon? I'm just kind of curious about the mass customization.
Yes, actually, we've done already some production for Volkswagen. Actually, it's a three-way arrangement with GKN, Volkswagen, and us. GKN being actually the factory. Where we already have produced certain parts. Actually, we started with an anecdotal part, which is basically producing a miniature of a car that Volkswagen gave away to their customers. And actually, we produced thousands and thousands of these parts. And for Volkswagen was actually a proof point that actually we could scale with something that has had a low risk. It was a giveaway, but actually the dimensional accuracy was so good, the repeatability was so good, the ability to the scale versus, for instance, laser melting was so quick in terms of speed and cost that actually now we are working actually on real parts that go on real cars, and we have actually a very aggressive roadmap of, as you say, customization, but not only customization.
Yeah. That's amazing, and it's exciting to hear. So, Ramon, I can't thank you enough for joining us today at our event. We really appreciate it. Again, as I mentioned to Greg Mark earlier, we certainly wish we had the opportunity to visit with you live, but this is the next best thing, and I'll look forward to seeing you again soon, okay?
A real pleasure.
Okay, thank you. Take care. So for those of you that want to learn a little bit more about the HP line of printers, obviously hit our website, hit HP's website. We have all the different links as it relates to our social media feeds and everything. We're going to be doing a live stream event on the HP line of printers, very similar to what we've done with our other partners. And we don't have a release date for that yet, but that's going to be coming out shortly. So take a look at again, subscribe to our newsletters and look for that information out there. So that wraps up today's general session. I surely appreciate everybody joining with us. Again, hit our breakout sessions later this afternoon, and have a great event, everybody. Thank you.